So now I'm going to tell you about a project that I and John and Jeroen, Sophie, Paul and Defu, Steve, who's at the back here, are working on at the university, looking at, this is kind of really a feasibility study, looking at what we can do with our data center waste heat. Is there stuff that we can do to make use of that asset that we've got? So, and the first thing I want you to bear in mind is that this is just a feasibility study. So what we're trying to do is test borehole drilling. We want to investigate the feasibility of, if you had a data center with generating a large amount of waste heat, can you store that heat between seasons? So store it in the summer, extract it in the winter. And so what we want to do is look at the ambient water flow through the mine systems that are underneath Durham. The Durham campus is above 2 levels of flooded mine workings. You've got the Hutton seam, which is kind of a 60 metre below the surface, and you've got the Busty seam, which is more like 150 metres below the surface. Now, and they were mined at different times. One was mined in the early 19th century, 1800s, the higher seam, and the lower seam was mined more recently in the early 20th century. And you've got some connectivity between those 2 layers where there are shafts going down and things like that. So you have, in principle, a massive thermal battery. What you can do is you can inject heat into one layer, extract cooler water from the other in a closed circuit, allow the warmth you've put in to flow along its layers, perhaps down or up, depending which one you're injecting heat into, and gradually spread the heat throughout connecting them. Then you might do this in the summer to get rid of your heat. In the winter, you reverse the flow, and then you can start to suck that heat back out. Now, of course, that only works if the water within the mines is a static body. If the water's flowing away, okay, it's great for getting rid of your heat, not so good if you want to reuse it, unless you happen to be lucky enough to live somewhere downstream of where that water is and can extract that there. Now, we believe that the water in these mines is static. It's we can't find any. It's not pumped anywhere. We know that. Some systems to the north of Durham are pumped mine systems, so there the water is continuing flowing. We believe this body underneath our site is not flowing, but this is one of the things we want to look at. It'd be flowing to some extent, but how much heat is there the potential there to save? So Durham University is a major HPC provider, one of the largest in the UK. 1.5 megawatt of waste heat on campus. Okay, there are also vague plans for a cross-site heat network, as in it was put into the estate's planning. They've realised they need to decommission their gas boilers and replace that with a heat network. So there are plans for that, nothing concrete as yet. So our project looks perhaps something like this. We start with the data centre, we pump heat into the mines, we extract cooler water, and then we can then use for heating buildings. We can take this warm water out of the mines, removing the heat from it, putting cooler water back in to the mines. So that's the plan. We want to investigate the feasibility of a scheme, something like that. Okay, so drilling 2 boreholes into these 2 seams. Now we had to choose location A, where the 2 seams overlap. So we can see the Hutton seam is in red, these red dots here, and that extends to kind of towards the left edge of the map. The Busty seam is the yellow, that extends a long way off the left edge of the map, but only comes to about the middle of the map. So where those 2 mines overlay is where we want to be. We also need it to be on university land, which is highlighted in green. And the area where those 3 criteria match up is this lighter area, I don't call that, but lighter area in the middle. So we put together this map, we showed it to our estates, the university estates, and said, okay, where can we drill? And they said, oh, great. They had a bit of a think and came back with a car park next to the Oriental Museum in Durham. And so we thought, okay, great, we've got a place we can drill. It then turned out that the one place in all of that the university was leasing out to someone else was that car park. So we were not able to drill there. So we went back to them and we said, okay, where can we drill? So then they gave us another car park. And it's a bit of an ongoing joke in Durham University about car parks that they like being built on and drilled through and things like that. So we're pleased to be using another car park. I guess it helps with net zero credentials and that sort of thing. So we have a site and yeah, there we are. I've said all that. We're working with Drill Corp and Town Rock. We've got a system design starting shortly. We went out to tender for this. They won the tender. It's been quite a process getting the university to kind of work out what they need to be doing, but we're slowly, I hope, getting there. We've got a water feature survey on the way. It does actually strike me slightly strange why the Environment Agency need water feature surveys. Most you think they would know all this. Anyway, it turns out they do. They just want us to put it in a presentation to give to them, something like that. Anyway, insurers have been pacified. The university is on side as the university gets. One of the things that we do to help with the kind of the insurance issues and that, we've engaged a company called TerraMotion who are able to look at ground movement over the past 10 years and using satellite data. I think it was Sentinel-2 from memory. And this map basically shows overlaying a map of the site, which is should be pretty much in the middle of the screen. Looking at how the surface of the land has moved over the past decade, and that plot in the bottom shows the 3 meter by 3 meter square where we're proposing to drill. The scale on the left, and you've got years along the bottom. The scale on the right, the vertical scale, is in meters. So you can see there's been today, before we start drilling, there has been very little ground movement. Okay, and the university the insurers want to know this because it means that after we've done our drilling, if we gain 10 years time, we look back at the data in 10 years time, we say, oh, it's moved a lot. Oh dear, that's our fault. Or hopefully it hasn't moved at all. So that's stuff that we can do there. So next steps for this, well, borehole drilling. I very much hope 2020. Last time I presented this slide, I was saying, well, maybe end of 2025 or early 2026. Delays at the university meant that didn't happen, but hopefully, very much hopefully, 2026. Then once that's drilled, we can start doing the instrumentation, the experimentation, doing follow-up projects around that and identify findings to the university. So I want to point out again that this is not a production system. We're not actually coupling the data center to these boreholes. We're just using the boreholes to investigate the flow of water, natural flow within the mines, and also the heat storage retention capability. So we can generate some heat, pump the heat down there, look at how quickly that decays and that sort of thing. So to actually put this into production, more work, more investment was required. We've done extensive modeling using the GEMS toolbox, which hopefully you've heard of. This image here is well, I think what Steve's going to be talking later, and Callum as well, more about that. But this just shows some of the modeling we've done, looking at pumping heat in and out through these different seams. Another conclusion that working with university estates departments is difficult. I already knew that, but I didn't appreciate quite how difficult before I got involved in this project. And of course, any advice, any comments, that sort of thing, if you think that could help this project, very welcome. So I think that's everything. Thank you.